यस सर।
हाँ कोई नहीं, वो तो होता ही है ना, पढ़ाई में होता ही है, कोई नहीं हो जाएगा, डोंट वरी। आप लोगों ने अच्छा मेहनत किए हो तो अच्छा रिजल्ट ही होगा, देखिए। ठीक है, ओके सर स्टार्ट।
यस सर।
हाँ ठीक है, कुछ प्रॉब्लम करते हैं ना। तो पहले आपका पहला जो क्वेश्चन है, ठीक है, तो आपका HCl मॉलिक्यूल है, ये प्योर वाइब्रेशनल स्पेक्ट्रा शो करता है, ठीक है। और इसका जो फोर्स कांस्टेंट के है, ये आपका है 480 न्यूटन पर मीटर है। ओके, नहीं इसको 100 लो, दूसरा प्रॉब्लम में इसको 480 लेंगे, इसमें 100 यूज करो। ओके, और सिस्टम का टेम्परेचर जो है आपका 300 केल्विन है, ठीक है। HCl मॉलिक्यूल है और वाइब्रेट कर रहा है, ठीक है, प्योर वाइब्रेशनल स्पेक्ट्रा शो कर रहा है। इसका टेम्परेचर जो है आपका 300 केल्विन है और फोर्स कांस्टेंट कितना है, 100 नैनोमीटर है। तो उसका एम्पलीट्यूड निकालना है। एम्पलीट्यूड कितना होगा, ठीक है। तो ये, हाँ ये वन डायमेंशनल वाइब्रेशन है, ठीक है, ये भी हिंट्स दे रहा हूँ, वन डायमेंशनल गिवन है। यस, सो हाउ विल डू दैट। सो वन डायमेंशनल अगर है आपके पास, अगर वन डायमेंशनल मेंशन है, तो फिर क्या यूज करोगे आपका, इसका टोटल एनर्जी कितना होगा बताओ। अगर वन डायमेंशनल है तो क्या यूज करेंगे हम, x²/2m प्लस, वाइब्रेशनल है तो फिर हम क्या यूज करेंगे, हाफ के x², राइट। And according to principle of equipartition theorem, each degree of freedom carried how much energy, 1/2 kVt, right? तो इसका भी हाफ केवीटी हो जाएगा, इसका भी कितना हो जाएगा, हाफ केवीटी। तो टोटल एनर्जी आपको मिल गया, दैट इज केवीटी, राइट। हाफ केवीटी प्लस हाफ केवीटी, दैट विल बी केवीटी। एंड टोटल एनर्जी goes to how much, हाफ के स्क्वायर। ये आपका के फोर्स कांस्टेंट है, राइट। So it means amplitude will be how much, twice kVt divided by k. This is your amplitude. So now you know everything. So amplitude will be 2 into 1.38 into 10 to the power minus 23. Okay, then you have temperature, that is also provided 300 Kelvin, and you have k. K is how much, 100, right. Calculate how much you will get. So if you calculate it, you will get 9.09 into 10 to the power minus 12 in meter. Okay, so this kind of question they may ask. So they may provide some other molecule also. They may give you some carbon monoxide or copper, they may provide, but process is same. Okay, so if it is one dimensional harmonic oscillator, obviously same energy will be kVt, right. That you people have done this kind of thing in heat capacity, right, classical heat capacity, that there you have three-dimensional case, so we got 3 kVt, right? 3 kVt. So from here you have derived 3R, right? So the same thing I am applying here. So you have total energy kVt, and that you know for harmonic oscillator it is half k square, and A is your amplitude, k is your force constant, so you can easily calculate. Okay. Is this part clear to all?
Yes, sir.
Shall I erase?
Yes, sir.
Okay. Again, similar problem. So molecule is again same HCl molecule you have. Okay. Again, it is showing pure vibrational spectra, and its frequency of oscillation is given. Frequency is given F. Okay. And you have to calculate that frequency of oscillation for DCl molecule. Here they have mentioned that mass number of chlorine is 35. Okay. DCl, D means what here? So frequency you have to calculate. That we don't know. What will be the frequency of vibration? So D means what here?
Deuterium.
Sir, 2.
Good.
Sir.
So it is nothing but deuterium, right?
Yes, sir.
Okay, now can you calculate? So you know that frequency of oscillations. That time I told you this kind of question they may ask. So for vibration, frequency of oscillation, how will you derive? So let us denote for hydrogen HCl, it is a new HCl. So it will be nothing but 1 by 2 pi root over K by mu, right? Mu of HCl. And let us denote for DCl molecule, it is like this. So it will be 1 by 2 pi root over K by mu into DCl. So you know that every notation you know, right? Here K means your force constant, mu is reduced mass. Now let us take this. This is your equation number 1, and this is your equation number 2. Okay.
Sir, root 2F.
Sorry.
Root 2F. Sir.
Root 2f or 1 by root 2f. Please check. So if you divide equation 2 by 1, okay. So how much you will get now? So it will be
F by root 2.
good. So one, please check your calculation. So now these things you know, that is they mentioned this frequency, that is for HCl, that is F. So I'll substitute directly here, and that will be K will be cancelled. So simply you will get what you will get, reduced mass of HCl divided by reduced mass of DCl. Okay. Okay. Now how will calculate reduced mass of HCl? So I told you that trick, right? So it's very simple. So it will be mass number, right? Mass number of this fellow is how much? The ordinary hydrogen is 1 into chlorine, that is 35, right? Divide by 1 plus 35 into Na.
Na.
Right? Na is your Avogadro number. If someone has problem, you can go through my previous class. So basically you have to divide by mass number, Avogadro number here, and here also. So on Na will be in denominator, and same thing for DCl also will get similar kind of pattern. So here in DCl this will be 2, right? 2 into 35 divided by 2 plus 35, and you have Na. Just it substitute here, here. So if you substitute here, then you will get nu of Hcl, and that will be simply f times square root of 35, right, divided by 36 into twice 35, and you have here 37, right? So this will be cancelled. This will be cancelled, and if these things will give you almost 1/2, right? 2 into 36, and ऊपर आपका कितना है 37. So if you calculate it, it is almost how much it will be the frequency. It will be almost f by root. Okay, and you can mention that unit also. Since you are writing frequency, you have to mention unit also. So it will be in a hertz. So in the question, they may ask, they may provide you that frequency value, and they may ask you to calculate frequency. Not only that, they may ask you to calculate wave number also, another parameter. But you know everything, right? You are smart about that. So how to calculate, convert from wave, frequency to wave number, another parameter, right? Like energy or wavelength. So if you know one thing, you can calculate all other parameters. Okay, is this part clear?
Yes.
Okay, next problem. Okay, next problem, you have HCl molecule again. Okay, its force constant K is given. That is, I have written that time, that was 480 nanometers. Okay, and its reduced mass also they have provided, that is 1.62 into 10 to the power minus 27 kg kilogram mass. Okay, now they have asked that your it's showing pure vibrational spectra, pure vibrational spectra. That is practically not possible. Okay, pure vibrational spectra they showed. Now they ask if that oscillator is at second excited state. Now that oscillator is at second excited state. Can you please mute your mic? Can you please mute your mic? Can you please mute your mic?
सावित्री ये पतीला धो के दे दे एक बार तेरे हाथ में जो है डंडी वाला ना स्टील का पतीला दे दे सावित्री
Swati, can you please mute your mic?
जितना ये मान बनेगा इसको देख लियो मुझे मान मान देती नुस्खे
सर आप म्यूट कर सकते हो सर।
एक क्लास सुन रही है क्या वो मुझे क्लास शुरू कर लेना चित्रा सावित्री के लिए काल को मेरे सर पे रख दे मेरे अरे मजाक कर रही हूँ कुछ नहीं कह रही तुम दोनों का बखेड़ा स्पोर्ट है मेरे को ये ठीक हो जाएगा तो बच्चा खाना खा लो ना ठीक से
Sir, you can.
Yeah, I told her.
तेरा बेटा ठीक हो गया इस बार चित्रा
Okay, staff will take care. We have to proceed. Okay. Okay. So what are the question? So your oscillator is at second excited state. Okay. So you have to calculate amplitude of vibration. When that your oscillator is at second excited state, you have to calculate that amplitude. My God. So how will calculate this? So you know that force constant, amplitude, you know. So you can you calculate? How will proceed? So let me proceed.
Amplitude, sir.
You have
amplitude, sir.
amplitude. Okay.
Really?
So you know that energy, right? So when it is at second excited state, it means I'll take vibrational quantum number. It will be how much? Second excited.
Sir, 2.
Yes, it will be
Sir,
2.
third 3 से होगा, sir. 3.
No, you see.
Sir,
Ground
2.
state.
Yeah, sir. हाँ 2 होगा, sir. 2 0 1 2.
तो ये
Sorry, sir.
क्वेश्चन में आप लोगों का मिस्टेक हो सकता है ना, ये
Yes, sir,
हमेशा
yes, sir.
ध्यान देना, ठीक है। हार्मोनिक ऑसिलेटर के लिए जितना बोलेगा उतना ही है, और अगर आप
हाँ सर,
इनफाइनाइट स्क्वायर वेव के लिए जाओगे तो सेकंड एक्साइटेड मतलब
तो
इनका वैल्यू कितना है,
थर्ड सर, थर्ड.
3.
तो हमेशा ध्यान देना, ठीक है। चलो, ये तो आपका 2 हो गया, तो एनर्जी कितना आ जाएगा इसका, तो यू नो दैट एनर्जी एक्सप्रेशन दैट इज इन टर्म्स ऑफ ऑसिलेशन फ्रीक्वेंसी, इट इज h nu
Yes, sir.
oscillation,
5/2.
okay,
Yes, sir.
v plus half, right? So it means h nu oscillation, so you can mention 5/2 here, since v is 2 here, so you can mention this number here also, 5/2 h nu oscillation. Okay, so since you have written this question, I should erase this part. So you know this is your energy, and that will be comparable with what, half k a square, because this is all about the energy of your harmonic oscillator, right? Half m omega square a square, and in terms of force constant it will be like that, and that should be equals to 5/2 h nu oscillation, and new oscillation will be simply k by mu, right? And 1/2 factor will be there, of course. So you have 1/2 factor, then you have k by mu, right? And everything they have provided, so you can easily calculate. So k was how much? It was 480. There is no problem with unit, that is already given in SI unit. And what about that reduced mass? How much they have provided? 1.62 into 10 to the power minus 27 kg, right? Okay. So this is all about your oscillation frequency. So if you have calculate it, I have calculated, you will get around 8.7 into 10 to the power 13 hertz. Okay, so you have calculated this part. Okay, so everything you know, these things you have calculated, these things you know, this is given, so you have to calculate that amplitude. So you have, since you have calculated oscillation frequency, now your life is simple. So this 2 will be cancelled. So A will be simply root over 5 h nu oscillation divided by k, right? So it will be 5 into 6 point, Planck constant h, right? So 6.62 into 10 to the power minus 34. Then you have this frequency. Okay, so frequency just substitute it, 10 to the power 13, and then you have k also. K is 480, right? So this is all about your amplitude. If you calculate it, you will get around approximately 0.
So 1.53 angstrom.
1.5. You will get 0.24 into 10 to the power in angstrom. 5 into 6.6.
सॉरी, वो मैंने गलती कर दी, वो म्यू 1/2 पाई था, मैंने 2 पाई लिख दिया, सॉरी।
देखो एग्जाम में इसी तरह की मिस्टेक होता है।
हाँ सर,
ठीक है, तो थोड़ा जल्दीबाजी नहीं करके आप थोड़ा धीरे धीरे करो, ठीक है। ये आपका आंसर है। अब एग्जाम में क्या आपका ये भी दे सकते हैं कि फर्स्ट एक्साइटेड स्टेट के लिए, है ना, तो आपका होमवर्क है कि आपको फर्स्ट एक्साइटेड स्टेट के लिए निकालना है एम्पलीट्यूड। ओके, अब मैं आंसर लिख के दे रहा हूँ, आंसर आएगा एम्पलीट्यूड विल बी 0.19 एंगस्ट्रॉम। ये किसके लिए आएगा? फर्स्ट एक्साइटेड स्टेट के लिए।
तो उसके लिए 3/2 h
एग्जैक्टली। So nothing, you can do simply just have to what you have to do, I'm telling. Just if you do like this also, root 3 by 5 into this number, you will get this number. Okay, you do it. Okay, if this is done, then we have to proceed next topic, and that is really important for your exam. At least for net exam, this is really important. So shall I erase this part? And I'm happy to tell you tomorrow we'll finish this molecular physics. Okay, I'm expecting that tomorrow it will be finished. Shall I erase this part?
Yes, sir.
देखो आप लोग सारे चीजें जानते हो, जस्ट दो चीज है। एक तो आपका ऑनेस्टी एग्जाम में बहुत जरूरी है, ऐसा नहीं है कि आपको लगाना ही है, नहीं आता है तो। और दूसरी चीज पेशेंस है, ये दोनों का ही खेल है। ठीक है, मेहनत तो आप लोगों ने खूब की हो। ठीक है, ये दोनों आप ध्यान देना एग्जाम पे।
सर आपके ख्याल से कौन सी पार्ट पहले स्टार्ट करना चाहिए, पार्ट ए और पार्ट बी?
मैं हमेशा 75 नंबर क्वेश्चन से स्टार्ट किया हूँ, हमेशा।
यस सर, मैं भी सर पिछली बार
लास्ट क्वेश्चन से स्टार्ट किया मैंने हमेशा।
सर मैंने पिछली बार ऐसे किया था सर।
चलो ठीक है, अपना अपना है। अब मेरे को टीचर ने यही सिखाया था कि अगर आपको अच्छा रैंक लाना है तो आपको सी पार्ट अच्छे से करना है, और अगर क्वालिफाई करना है तो आपको बी पार्ट अच्छे से करना है। ठीक है, तो आपका चॉइस है। ठीक है, बट एक बार देख लेना चाहिए कि हाँ पीछे कोई आसान क्वेश्चन तो नहीं रह गया है ना। कभी कभी ऐसा होता है ना कि आप पहुंच ही नहीं पाया, वहाँ पे 1 मिनट का क्वेश्चन था, कोई 75 मार्क्स जो नंबर का क्वेश्चन है 1 मिनट में हो जाता है ना। तो एक बार देख लेना चाहिए आपको। ठीक है, चलो ठीक है, आप शुरू करते हैं रमन स्पेक्ट्रा। So you have substance. This is your substance. Okay, it may be solid, liquid, okay, or gas. When the substance that may be solid, liquid, or gas is exposed by a radiation, and that radiation basically lie in visible or UV region. So this is your incident radiation. That is your substance is irradiated by that electromagnetic radiation, and the part of electromagnetic radiation that is visible or UV. Okay, so this is your incident radiation. Its energy is h nu naught, and wave number is nu naught bar. So what is the outcome when he performed that experiment? He saw 3 kind of photons. So there is only one kind of photon that is incident, and at the outcome he observed 3 kind of photons. Okay, so one photon has same energy or wavelength as incident photon. So this photon has same energy, wavelength, or wave number as incident photon. Another another kind of photons has less energy or wave number as compared to incident photon. Okay, and another photons has higher energy or wave number as compared to your incident photon. Okay, so this photon that that has similar energy as with incident photon, this is known as Rayleigh line. Okay, in short form, it is the photons which has less energy or wave number. This is known as Stokes line. Okay, in short form, H dot O. The photons or which has higher energy or wave number as compared to incident photon, this is known as anti-Stokes line. Okay. And when they have performed that experiment, what they have noticed, and in fact, I must say that this anti-Stokes line and Stokes line are called Raman line. Okay, anti-Stokes line and Stokes lines are called Raman line. So in the experiment, what was the observation? So there is a sharp high intense peak. Okay, and there are two more lines beyond on the right side. So along x-axis, this is your wave number. Okay, so let me write this first, and this side you have intensity, y-axis. So there is on a high intense line, and at higher wave number there is a low intense line. Also on low wave number there is another line, but the intensity of this line is high as compared to this. So I will repeat it again. तो सबसे ज्यादा इंटेंसिटी तो सेंटर वाले का था, उसके बाद इसका था, और इसके बाद इसका था. So obviously from this picture it is clear low wave number means Stokes line, because right. So this is actually your Stokes line. Okay, so I'll write the notation. In notation I'll write it like nu bar S. Okay, you have, this is your anti-Stokes line, that is this okay, this is your Rayleigh line. So its energy or wave number is same as incoming radiation. So this is actually your Rayleigh line, and this is your anti-Stokes line. Okay, so let me write in notation, it will be fine. So it will be, this is your Rayleigh line, and its notation will be nu 0 bar. Because why I'm writing, because its wave number is same, right? So I can write like nu 0 bar, and this is your anti-Stokes line. So I'll write notation nu bar AS. So the this distance and this distance also they have observed that is same, delta nu bar. So the separation between Rayleigh line and Stokes line, that is known as Raman displacement. Also separation between Rayleigh line and separation between Rayleigh line and anti-Stokes line, this is known as Raman shift, and this Raman shift is same as separation between Rayleigh line and Stokes line. So this separation is same. So what I can write from this expression, what I can write, that this will be delta nu dash. What I can write from here? So wave number of this minus wave number of this. So wave number of anti-Stokes line nu dash is minus nu 0 bar, right? And this separation will be how much? So it will be simply nu 0 bar minus nu s, right? And that is same. So this, from this separation, what I can write, because a आपका क्या है, बड़ा है as compared to this, so nu 0 bar minus nu s. So this is actually this. And from this wave number corresponding to anti-Stokes line is high as compared to Stokes line. So this separation I can write like nu bar AS minus nu 0 bar. Okay. So if you compare these two equations, because these two are same, so what I can write that.
Sir, so this subtraction, can you explain?
Yes, this is nothing. Just if you are measuring length, how will measure that length? This point minus this point. तो इसका वेव नंबर कितना है? देखो, इनका सेपरेशन निकाल लो हम. तो ऑब्वियसली कौन सा बड़ा है? न्यू बार एस, राइट?
Yes, sir.
So न्यू बार एस minus न्यू 0 bar. So this is the separation. This is the expression for this. And here, which one is bigger? Nu 0 bar is right side as compared to nu s. So how will measure this distance? So nu 0 bar minus nu s. And I told you this separation and this separation is same. So I'll compare this with this. Now is it clear?
Sir, here US is greater than mu 0.
हाँ, ये आपका nu 0 bar है जो आपका
Yes, sir.
रैली लाइन.
Yes, sir.
हाँ.
SL ES में है ना सर?
सॉरी,
ये न्यू एस है ना सर?
हाँ, ये आपका न्यू बार एस. तो यहाँ से इसका डिस्टेंस मेजर करो, एक आपको ये मिलेगा.
ये सही, ये तो पॉइंट समझ गया, ये वाला नहीं आ रहा.
ये वाला नहीं आ रहा है, ये
Yes,
तो
sir.
और सिंपल है. इसको आपको ये मेजर करना है, तो कौन सा बड़ा है? ये बड़ा न्यू 0 बार, राइट? बिकॉज इट इज ऑन द राइट.
Yes, sir. Yes, sir.
तो न्यू 0 बार माइनस न्यू एस बार.
Oh, okay, sir. Thank you, sir.
Now since these are same, so I'll compare it. So if you compare it, then how much you'll get? Nu s bar minus nu 0 bar equals to nu bar as minus nu 0 bar. So if you rearrange it, so you'll get nu s bar plus nu bar as, and that should be equals to twice nu 0 bar. So you know this every parameter, because I already told you this is actually what? This is the wave number corresponding to Stokes line. This is the wave number corresponding to anti-Stokes line, and nu 0 bar is actually the wave number corresponding to Rayleigh line, and this is same. The Rayleigh line wave number is same as the incident line, right? Incident wave number. So in terms of wavelength also you can mention, like, because wave number is inversely proportional to inverse of wavelength, right? So in terms of wavelength, how it will look like? So it will be 1 by lambda s plus 1 by lambda s. That should be equals to twice 2 divided by lambda 0. So lambda s corresponding to the wavelength of Stokes line. This is the wavelength of anti-Stokes line, and this is the wavelength corresponding to Rayleigh line. So in the exam, they will provide you two wavelengths, and they may ask you, they will provide you that this value lambda 0 and lambda s, and they will ask you what will be the lambda s. Okay, so three wavelengths are given. So in exam, they will provide you two wavelengths, and they may ask you another value. Okay, is this part clear? So this equation is really important for your exam.
सर सेकंड लाइन सर उल्टा हो गई
जी.
और जो सर न्यू एस बार माइनस न्यू 0 बार है
हाँ,
इक्वल टू न्यू एस माइनस न्यू एस 0 तक. तो सर न्यू 0 बार पहले होगा न्यू एस बाद.
अच्छा, यहाँ पर yes. Thank you. This should be like this, right? Because this I am writing here. Okay, good, very good. Okay. So is this part clear? Shall I erase this now?
Yes.
Okay. Now actually, how these things is happening? What is the physics behind that that production of these three lines? That is really important to understand, right? So I'll go through this, then we'll go to that problem. So you know, H2 molecule. So how does that molecular structure look like? So it will be, you have positive center, okay, and there will be electron cloud, right? ठीक है, इस तरह की आपका इलेक्ट्रॉनिक क्लाउड होगा। अब अपने फील्ड लगाओ, इलेक्ट्रिक फील्ड अप्लाई करो। So I am applying electric field. So this side, let us assume this side you have positive polarity and this side negative polarity. So what will happen? This electron cloud will feel some repulsive force due to this similar charge, because this is negatively charged and the electron cloud is also negatively charged. On the other hand, this positive polarity will attract this negatively charged cloud. So there will be shifting of electron or negative charge here. So what will happen? This side you will get negative charge, and this side, so when there is a movement, this side will get positive charge. So what is actually happening?
Sir,
Yes.
sir, this point, sir, how negative is coming to the left side?
Exactly. Why it will not come? Because this side you have negative plate, and this side, if there is an electron here, so what will happen? This electron will feel repulsive force, right?
Yes, sir.
And also this positively charge will attract this, so this electron will come here. Okay. So you'll get what is actually happening. So it's clearly obvious that there is a creation of dipole moment. So there is a induced dipole moment due to the application of electric field. तो आपका क्या इंड्यूस हो रहा है? एक आपका डाइपोल इंड्यूस हो रहा है. Is this part clear to all?
Yes, sir.
Okay. Now, what is polarization?
Dipole moment per unit volume.
Good. So you know that polarization P is related to applied electric field. This thing you learned from electromagnetic theory, right?
Yes.
So this is actually polarization, and polarization is nothing but dipole moment per unit volume. And in fact, that polarization is proportional to applied electric field. So if you remove this proportionality from here, then how much you will get? Dipole moment will be, polarization will be alpha into E. And alpha is what? Basically polarizability. Right? Now, what is actually polarizability? पोलराइजेबिलिटी का सिग्निफिकेंस ये है कि आपका मटेरियल हाउ इट इज इजीली पोलराइजेबल. अगर पोलराइजेशन का वैल्यू ज्यादा है, इसका मतलब आपका मटेरियल बहुत इजीली आप उस मटेरियल को पोलराइज कर सकते हो. अगर पोलराइजेशन का वैल्यू कम है, तो इसका मतलब इट इज हार्ड टू बी पोलराइज. ओके, सो दिस इज द मीनिंग ऑफ पोलराइजेबिलिटी. So it basically tell you how easily your material can be polarized. If that value is large, it means you can easily polarize. If this value is less, then that material is hard to be polarized. Okay. Now another thing, this is your electric field. You have applied electromagnetic radiation, right? You have applied electromagnetic radiation. So the electric field is oscillating here, right? Is this part clear? Because that, yes, that electromagnetic field, electromagnetic wave, both electric field and magnetic field, both are oscillating, right? So this is actually oscillating in nature. So what you can say? If this is oscillating in nature, then P should be oscillating. Did you get what I'm saying? अगर ये oscillating है, So what you can say, this should be oscillating, no? Or else I'll draw the picture, then it will be clear. So if you have completed, I'll draw that picture. Shall I erase this part?
Yes, sir.
So I'll use some similar kind of thing like capacitor. Okay. So this is the source of electromagnetic radiation that basically providing UV visible light. Okay. So for the time being, let us assume in first cycle that polarity in the plate or capacitor plate is like this, and your molecule is since I've taken hydrogen molecule, I'll use like this. And due to the polarization, let us assume there is a shifting of electron is like this. So polarization का कारण इस तरह की आपका चार्ज का इंडक्शन हुआ है, डेल्टा प्लस एंड डेल्टा माइनस. What I discussed in that previous discussion. Okay, so polarization के कारण आपका क्या हुआ है, some charge induction is happening in this polarity, it is delta plus, and this polarity is delta minus. Okay, so of course the dipole moment will be in this direction. Okay, in next next cycle, what will happen? So now for this time, that dipole moment is along this direction. In the next polarity, what will happen? That this side since there is a change in polarity, so this side there is an induction of negative charge, and this side there is induction of positive charge. Now you see your dipole moment is changing direction, right? So due to this oscillating, is this part clear to all, or I have to repeat it? Is this part clear to all? हाँ, ये तो पहले वाला सिनेरियो हो जो मैंने बड़ा करके ड्रॉ किया था. दिस इज द फर्स्ट सिनेरियो. Now, since this plate, the charge of the plate is actually changing with time because you have electromagnetic wave. So next cycle में क्या हो जाएगा, इस प्लेट में पॉजिटिव चार्ज आ जाएगा, इस प्लेट में नेगेटिव चार्ज आ जाएगा. तो obviously this side you have negative charge, induction of negative charge, and this side will have positive charge, right? Sorry, this side, so I made some little, this should be negative, this should be positive, and this should be positive, this should be negative. Because इस साइड ऑफकोर्स क्या करेगा, नेगेटिव चार्ज को अट्रैक्ट करेगा, तो इस साइड आपका नेगेटिव हो जाएगा, और यहाँ से चार्ज चला गया तो पॉजिटिव हो गया. दिस साइकिल में क्या हो जाएगा आपका, नेगेटिव चार्ज इस साइड चला जाएगा, है ना. तो डाइपोल मोमेंट एक्चुअली फॉर दिस साइकिल, प्लीज एक्सट्रीमली सॉरी
सर, Cl ऊपर आएगा ना, मतलब, और हाइड्रोजन नीचे.
हाँ,
पहले डायग्राम में अभी जो आप चेंज कर रहे हो उसमें Cl ऊपर आएगा ना.
हाँ यस. तो इस साइड आपका क्या आ जाएगा, आपका इस साइड आपका डाइपोल मोमेंट आ जाएगा. this cycle you will have dipole moment will be in this case. So actually what is happening, dipole is actually oscillating with changing that polarity of electromagnetic wave. Is this part clear? Is this part clear to all?
yes sir. सर इसमें रोटेशन कुछ नहीं होगा, सिर्फ ऑसिलेट करेगा.
No, yes, there will be rotation also. Dipole कैसे आएंगे, रोटेट करके आएंगे नहीं?
yes.
Yes, so there will be rotation also.
Sir, oscillation means charge oscillate कर रहा है ना sir.
This dipole will rotate, so it will from the here it is like that, in next cycle it will rotate.
So force कहाँ से मिलेगा इसको? Force कैसे मिला? How it is getting the force to rotate?
You see, force मिलेगा due to.
Sorry, torque.
Torque कहाँ से मिलेगा?
Yes sir, how it is getting the torque?
Yes, that's a good question. But you see, it's not always that molecule will be in this scenario, right? So there
Yes,
may
sir.
be some angle also. How you know that that molecule will be itself in this direction, right?
Sir.
आपके पास बहुत सारे molecule है, नहीं?
Yes, sir. Of course.
So many molecule will be some angle, right?
Yes, sir.
So there will be rotation. So dipole is actually oscillating here, and that oscillation will have same frequency. Oscillation will have same frequency of incoming EM. अगर डाइपोल आपको ऑसिलेट कर रहा है तो अकॉर्डिंग टू इलेक्ट्रोमैग्नेटिक थ्योरी that oscillating dipole will produce EM radiation, and that frequency of that EM radiation will be same as the frequency of oscillation. And ये जो oscillation है किसके साथ मैच करता है?
Incoming.
At least you learn that how that Rayleigh line. So due to that oscillation of your dipole, there is a creation of EM radiation, and this EM radiation will have same frequency of oscillation, and this frequency of oscillation is actually equal to the frequency of incoming radiation. So this line is basically what then? This line is basically what?
Rayleigh line.
Exactly. So at least this is actually your Rayleigh line. Is this part clear?
Yes, sir. So here oscillation means they are rotating, right?
Yes, you can say.
And due to rotation only this output is being generated.
Yes.
Okay,
Like
sir.
we have discussed in rotation also. And there is not only rotation, depending on that scenario, there is a vibration also. So there are basically two kind of Raman scattering. One is rotation and another is vibration. Okay. So I'll discuss this part, but the thing is that when you will apply that electromagnetic radiation, there will be oscillation of your dipole, and that dipole have oscillation frequency equals to the frequency of EM radiation. So due to the oscillation of your dipole, there is a creation of EM radiation. So this is basically your Rayleigh line. Okay. So in notation, what you can write, if your electromagnetic field is E naught sine. Now what I'll write here? Nu naught, because I already considered this the frequency of incoming radiation is nu naught, right? So it will be like this.
सर
Yes.
यहाँ आपने लिखा है ना उससे डायपोल तो रोटेट हो रहा है, लेकिन वो ऑसिलेट कैसे होगा, मतलब नहीं समझ में आ रहा। डायपोल रोटेट हो रहा है ना वो।
हाँ, देखो रोटेट मतलब क्या हो रहा है एक्चुअली, ऐसा आ रहा है ना,
एंगल चेंज हो रहा है। हाँ
ऐसे जा रहा है, ऐसे ही हो रहा है कुछ, but at the same time there is a rotation also. I'll tell you, I'll come to that topic, how there is a rotation also. So there are two type of basically phenomena. One is rotational Raman spectra and another is vibrational. So at this scenario, you just mentioned there is an oscillation of your dipole due to change in the polarity, and that oscillation basically creating your Rayleigh line. Okay. Now you got this thing, right? P equals to alpha E naught sine 2 pi nu naught into T. Now alpha is not constant here. Alpha is not constant because there is a rotation of molecule also. Now I'll tell you. Suppose आपके पास इस तरह की सिनारियो है, आप बताना कौन सा मॉलिक्यूल का रोटेशन हो रहा है ना, रोटेशनल रमन स्पेक्ट्रा में हम पढ़ेंगे, तो मॉलिक्यूल एक्चुअली कैन रोटेट ऑल्सो. तो रोटेशन में आपको डिफरेंट डिफरेंट कॉन्फ़िगरेशन मिलेंगे, राइट? अब इसमें बस इसमें से बताओ, जब मॉलिक्यूल रोटेट कर रहा है तो इसका कॉन्फ़िगरेशन डिफरेंट डिफरेंट होगा, राइट? तो इसमें बताओ, इसमें मॉलिक्यूल को पोलराइजेशन करना इजी है और इसमें है? कैन यू प्लीज टेल मी? So when there is a rotation,
Second part.
when there is a rotation of molecule, there will be rotation. I'll discuss rotational and vibrational Raman spectra. So there is a rotation of your molecule also, you know. So when the molecule will rotate, it will have different configuration. So I have drawn two configuration. There will be many configuration, but in between these two, which one will be easily polarizable?
Second one.
Second one, right? So what I can say, यहाँ पे आपको क्या मिलेगा? अल्फा जो है मैक्सिमम मिलेगा, क्योंकि इजीली पोलराइजेबल मतलब क्या है? यहाँ पे पोलराइजेबिलिटी मैक्सिमम है। यहाँ पे दिस इन दिस कॉन्फ़िगरेशन दिस मॉलिक्यूल इज हार्डली पोलराइजेबल, राइट? तो यहाँ पे आपका अल्फा क्या है? एक्चुअली मिनिमम है। इट मींस एक्चुअली ड्यूरिंग दैट रोटेशन ऑफ योर मॉलिक्यूल, अल्फा इज नॉट फिक्स, इट इज एक्चुअली oscillating. Okay, this part clear? Sautan, Abhishek, Varun, Kiran, is this part clear what I am saying? So there is a rotation of your molecule, right? And during that rotation, your alpha is not fixed. It is actually oscillating. So it is getting minima, then maxima, then it will get minima, maxima. Okay, so alpha is not constant here. Is this part clear what I am saying?
Yes.
Okay. So alpha can be expressed as alpha equals to alpha naught beta, and let us take that oscillation frequency of your polarizability, that is new oscillation. So what I can write, beta sine 2 pi new oscillation into t. So this is your alpha. Now I'll substitute this alpha here. So I'll get the dipole, it will be small capital, so it will be alpha naught plus beta sine 2 pi new oscillation t, and you have this E naught sine 2 pi nu t. Okay, so if you rearrange it, so we'll get alpha naught E naught sine, this will be nu zero, right? This will be nu zero, so it will be sine 2 pi nu zero t, and from second and third term, so second and third term it will give you beta E naught. Now I'll divide by 2 and I'll multiply it by 2. 2 sine 2 pi new oscillation t plus sine 2 pi nu naught t. So you know that 2 sine A sine B. The formula is what?
Sine 2.
So what is the formula? So it will be alpha naught E naught sine 2 pi nu naught t plus beta E naught by 2 sine A sine B, that is cos A minus B minus cos A plus B, right? Good. So cos 2 pi nu naught minus new oscillation into t minus cos 2 pi nu naught plus new oscillation into t. Okay, so you see there are three frequencies. So dipole can oscillate in this frequency. So when dipole is oscillating at nu naught frequency, it will give you Rayleigh line. So this is actually classical picture, you know. Everything I have used, that is classical theory, right? And this frequency, dipole can oscillate in this frequency also, nu naught minus nu oscillation. And this frequency actually, when the dipole will oscillate in this frequency, it will produce which line? Rayleigh line, right? Sorry, Stokes line.
Stokes line, sir.
Okay, Stokes line it will produce, and in this frequency, when dipole will oscillate in this frequency, it will produce anti-Stokes line. So this is the way how that classical theory explained. There are three lines. Okay, when the dipole is oscillating at nu naught frequency, it will produce Rayleigh line. When it is oscillating at nu zero minus nu oscillation, it will produce Stokes line, and nu zero plus nu naught oscillation, it will produce anti-Stokes line. So this is the beautiful explanation of classical theory, but failure is it can't explain how that intensity distribution actually, how that Stokes line has more intensity as compared to anti-Stokes line. Okay, in fact, it cannot explain that distribution of intensity. Okay, then the theory came, that is quantum theory. Is this part clear? अगर कोई डाउट हो तो बोलो.
सर इसमें न्यू ऑसिलेशन और न्यू नॉट दोनों सेम नहीं होते?
नहीं, दोनों सेम नहीं.
क्यों सर? ऑसिलेशन तो
the explanation is that polarizability, frequency of polarization is twice high as compared to the frequency of rotation.
Oh, okay.
That's why.
Sir, please repeat the reason you have said now.
Frequency of polarizability is twice as the frequency of your frequency of incoming radiation, or frequency of rotation actually. So you can mention like the frequency of polarizability is twice as the frequency of rotation. That's why that nu naught and nu oscillation will not be same.
लेकिन वो जो लाइन मतलब वेव एमिट होती है उसकी फ्रीक्वेंसी इंसिडेंट फ्रीक्वेंसी से सेम होती है ना? अभी
कौन सा लाइन?
देखा, सॉरी नॉट लाइन, इलेक्ट्रोमैग्नेटिक वेव जो बाहर आती है उसकी फ्रीक्वेंसी सेम होती है ना इंसिडेंट रेडिएशन की?
हाँ, that will produce Raman line. This one. But Southern asked, that's a deep question. He is saying why that nu oscillation and nu naught is not same. So that explanation is like that your frequency of change in polarizability, that is twice as that of frequency of rotation. So that's why this frequency will not be same, because you know that frequency of rotation is actually depends on what factor. This is depends upon nu naught, right? Is not it? आप रोटेशन एक बार रोटेशन हो रहा है मतलब 1 सेकंड में एक बार रोटेशन में हो रहा है, मतलब क्या है कि आपका जो इनकमिंग रेडिएशन है उसका फ्रीक्वेंसी ये है, ठीक है ना? अगर did you get what I'm saying? जो आपका फ्रीक्वेंसी ऑफ सडन did you get what I'm saying?
हाँ सर, रोटेशन तो इनकमिंग से डिपेंड करता है.
So according, so what is the concept? Concept is that the frequency of polarizability actually twice as that of frequency of rotation. So that's why this will not be the same. Okay. So this kind of question is this time on competitive exam they have given like this. So what they have given? They have given simply this equation, you know, E equals to something A cos omega 1 t and cos omega 2t, and they what they ask that in the spectrum which frequency will not be available. So it was actually based on Raman spectra. तो इसमें अगर आप इसको ये करोगे टू ट्वाइस कॉस करके आपको जो इस तरह की टर्म मिलेगा, राइट? तो उसमें पता चल जाएगा स्पेक्ट्रम में कौन कौन सा आपको फ्रीक्वेंसी मिलने वाला है, राइट? डू यू गेट व्हाट आई एम सेइंग?
So what is its drawback, sir? Cannot explain intensity.
Intensity. So if you see when I have drawn that intensity distribution, then that Rayleigh has high intensity, right? Then उसके बाद किसका इंटेंसिटी ज्यादा था? स्टोक्स का. एंटी स्टोक्स का इंटेंसिटी सबसे कम था. इंटेंसिटी डिस्ट्रीब्यूशन कैन नॉट बी एक्सप्लेन बाय क्लासिकल थ्योरी. Then quantum theory came. So there is a nice explanation. So if you remember, suppose this is your vibrational level. Okay, this is V equals to 0. Let us assume this is your E1 state. V equals to 1. This is your E2 state. Okay, and another, let us assume rotational level. J equals to 0. That is E1. J equals to 1. That is E2. Okay. So of course that separation. Yes, separation is how much? Separation is how much? Here delta E equals to 0.001 electron volt. Okay, and in this separation is basically how much? So this separation delta E, that is basically 0.1 electron volt. आप UV and visible light use कर रहे हो, इसका frequency कितना होता है? This frequency of UV and visible light basically lie in the range of 1 to 10 electron volt. ठीक है? Here also, if you expose this same light 1 to 10 electron volt, is this possible to excite the molecule from ground to upper level?
No.
No, because there is a restriction. So how the thing is happening actually? So in that quantum system, you know, there is always exists some virtual level, virtual states. Are you familiar with this? In quantum system, you always have some virtual states. So I'll draw this level again. So you have, अभी थोड़ा इसको एक्सप्लेन करके थोड़ा ये करेंगे ना, ब्रेक देंगे. कितना हुआ टाइम अभी? 7:40. Okay, so it should stop for 5 minutes, then we'll discuss. Okay.